Water is one of the most common substances in the world. Indeed, about 70% of the Earth's surface is covered with water in the form of oceans, in some places to the depth of more than 35,000 feet. In our own Pacific Northwest, we may find as much as 12 feet of water coming down in the course of a single year as precipitation. In the Philippines, all the way over on the other side of the world, there was a tremendous record rainfall that brought down in 48, when in 12 hours, 24 inches of rain came down in a deluge. Yet we find many areas in the world which have been cut off from this moisture, deprived of the moisture which originally comes from the ocean. This moisture has been eliminated from these areas for a variety of reasons. In some cases, there are great mountain barriers, such as the Rocky Mountains, which cut off moisture, and on the leeward side, or the side away from the prevailing moisture, we find the development of the dry areas. Many of the dry areas, grasslands and deserts, occur in the center of continents, away from ocean moisture, generally in the so-called horse latitudes, north and south of the equator, which are characterized by high-pressure systems and clear air and dry air. Where the precipitation across the surface of the Earth is more than 10 inches, and yet does not exceed usually 30 inches, in other words, is insufficient for the development of trees, either from the total amount of precipitation available or the good distribution of the moisture, we find thriving the grasslands of our Earth. Many of these grasslands are famous areas. For example, the steppes of the Eurasian region of the world, the grasslands which surround the center of Australia, the grasslands which edge the desert regions of Africa, the southern pampas grasslands of South, and in our own continent, the great grasslands of our plains region. In addition to these steppe and temperate grasslands, we have in the world what are called tropical grasslands, not indicated on this map. The tropical grasslands are characterized by a tremendous amount of precipitation, but coming just at one time of the year, the rest of the year being dry. We find such grasslands in particularly of Africa and South America. Where the precipitation declines below 10 inches a year, we find the grasslands of the world giving way to the deserts of the world through transitional zones known as ecotones. Among the famous deserts of the world, we recognize the Gobi Desert and associated deserts in Asia, the Great Barren Deserts, center of Australia, the Patagonian Desert in southern South America, the Atacama along the west coast of South America, in Peru and Chile, our own southwestern deserts in North America, in the African region, the Kalahari Desert at the southern tip, the Arabian Desert, and the vast Sahara Desert. To gain some appreciation for the size of some of these desert areas, imagine walking across the Sahara Desert, a desert which is wider than the entire width of the United States. One comment should be made on some of these desert areas that develop in close proximity to the ocean. For example, this South American desert. In this particular case, we have moisture available, but it is cool water. being cooled by a current coming up from the Antarctic along the edge of the landmass. As this cool, moisture-laden air from the ocean passes into the dry interior of the land, that dry air of the land takes up the moisture but does not give it back in the form of precipitation. And so we find the development of deserts in regions like that and regions like this. As we look now at the map of the world, we can readily appreciate that almost 50% of our exposed land masses are semi-arid and arid regions, the grasslands and the deserts of the earth. In addition to a lack of moisture, grasslands and deserts share other physical factors. For example, topographically, deserts and grasslands are typically flat or rolling, great open spaces, so to speak, a land of monotony for many people. Deserts particularly are broken by hills, by isolated buttes or mountain ranges, and by ravines. In these semi-arid and arid countries, the winds are incessant, creating sandstorms and dust devils, on the Great Plains, seasonal blizzards, and devastating tornadoes or twisters. The evaporation rate is high with a correspondingly low relative humidity, sometimes only 5 or 10%. Temperatures in grassland and desert are variable, and there are great extremes seasonally and daily. For example, in the Salton Sea region of the Southwest, there may be as much as a 60-degree difference between night and daytime temperature. Grasslands typically are hot in the summertime, cold in the winter. Deserts are scorchingly hot during the daytime, chilly at night. The hottest temperatures ever recorded on the surface of the earth have been recorded in deserts, 134 degrees in Death Valley, which is fairly warm, and 136 in the Sahara Desert. To give some appreciation for the extent of hot temperatures in desert regions, in Death Valley there was one period where the temperature reached 100 degrees or more for 538 days. Speaking of days, they're sunny in these kinds of regions, very little cloud cover, and as a result of this, many of our southwestern desert towns highly advertise their sunshine and will give free lodging on days when the sun does not come out. Yuma, Arizona, one of the sunniest towns in the United States, has sunshine 90% of the hours when the sun happens to be out during the course of a year. Because of the cloudless skies, there's very little insulation or protection for the ground. This accounts for the variable temperatures, the heat being lost at night into the air, the heat being retained during the daytime. Although there's very little moisture, when it comes in a deluge, creating flash floods, the gully washers. Most of the moisture in these areas will come in the springtime or the early summer. Late summer is a time of very, very dry conditions and very hot temperatures. Because of the generally unvegetated or poorly vegetated countryside, particularly the uplands, rains and winds create spectacular erosional features, such as those we find in the Grand Canyon and Monument Valley of the Southwest. Surprisingly enough, the soils of grassland and desert are rich in minerals. They are called pedocles, or they are that group of soils characterized by a large concentration of calcium. The minerals in this soil does not wash out due to excessive moisture and consequently can be available for good agriculture with irrigation. On the other hand, poor land management in these regions may produce alkali flats. Leaving the deserts for a moment, we now turn our attentions to the grassland regions of the world. Since grasslands occupy large extents of the Earth's surface and are characterized by certain interrelated plants and animals, we can speak of the grasslands as making up a major community called the grassland biome type. We might turn our attention to a local grassland biome that occurs in North America. The grassland biome in our own country is of vast extent, ranging from the Great Lakes on the east out to the Rockies on the west and from central Canada down into Mexico, with small bits of grassland in the Central Valley of California and in the Pacific Northwest. On all hands, this grassland biome comes in contact with many other kinds of vegetational biomes. Looking at the grassland biome in cross-section, we can see a great range in variations from east to west. In the east, in the Great Lakes region, certainly in the past at any rate, we would have found the tall grass prairie, wonderful tall grasses standing sometimes as high as a man's shoulders. As one proceeds farther west, where there is less and less precipitation, we find the development of mixed grass prairie, where we have the tall grasses, intermediate grasses, and short grasses underneath. And then farther west, where it becomes quite semi-arid, we find the development of the short grass. Throughout this vast extent of grassland, as varied as it may be, there are certain species and genera of grasses which occur time and time again. These are the so-called binding dominants. Plants like the blue grama and the needle grass, which are repeated throughout the extent of the grassland and tie the grassland biome together. In any particular region of the grassland, we would find isolated communities made up of one or two dominant kinds of grasses characterizing that particular region. The grama buffalo grass association is an example of this small kind of community. This association is maintained by misuse of the land, by overgrazing that keeps out the taller grasses so characteristic of the Middle West and East. The most successful grasses which one finds in the grassland biome are the perennial grasses, those grasses which live year after year, dying off during the wintertime above ground only. The perennial grasses may form clumps or bunches and consequently are known as bunch grasses, or they may form a very extensive sod and are known as sod grasses. In addition to the perennial grasses, we do find many annual grasses, some of them indicating misuse of the land, like the cheatgrass, and during the summertime and springtime we find a vast, colorful panorama of flowers in bloom. The trees, if they exist, will be along the watercourses or have been planted by man, as is true of the windbreaks in the Dakotas. In any biome, we find not only characteristic plants, but also characteristic animals. And in the grassland biome, these animals are well adapted to survive under the rigorous conditions which they encounter there. An organism's relationships to its community is known as an ecological niche. And in the grassland, we find a number of interesting broad ecological niches occupied by the animals. For example, we find a large group of animals which run, characterized here by the coyote, which can clip along at the rate of 45 miles an hour. Another group of animals in grassland country are jumping animals, animals like the jackrabbit here and animals like the kangaroo in Australia. The kangaroo, incidentally, can jump as much as 25 feet in a broad jump, which is rather good, and our jackrabbit can perhaps jump 10 feet in a broad jump. Still other animals seek protection for their environment through a digging way of life, like the badger. The badger can dig so rapidly that by the time I could walk to the back of this room, the badger could dig himself out of sight into the ground. Still other animals take different ways of escaping the rigors of the environment. During the summertime, when it gets very hot and where there's very little food or water available, many of our animals in the grassland country go to sleep in what is known as a state of estivation. In the wintertime, the same group of animals and others joining them go into a winter sleep to escape the rigors of the wintertime, a winter sleep being called hibernation. And still another variety of animals leave the countryside and go to more pleasant climes, going through a process which is known as migration. Grassland animals have a number of other adaptations for survival in their particular kind of a habitat. Many of them, for example, are protectively colored in browns and grays and blend into the grassland. Others are gregarious, gathering in large flocks, as the bison used to do, in herds that numbered up into the millions. Many of these animals have acute senses of smell, of sight, of hearing. The birds typically nest on the ground. It's difficult to nest in a tree where there are no trees, and also sing on the wing, which is a rather interesting adaptation. In any particular kind of a biome or community, we would expect to find certain characteristic animals, like the binding dominant plants that occur in the grassland country. These animals are known as indicators, and we have some fine ones in the North American grassland biome. One of the best being the badger. Wherever you find grassland country, you find badgers throughout the Great Plains region and the eastern prairies, and even out there in the Central Valley of California in the grassland. Another good indicator of grassland is the pronghorn antelope. Indeed, this biome is known as the Grama pronghorn antelope biome. Also, we have animals which have exerted a tremendous influence on the biome through the years. The greatest influence of our grassland biome is the buffalo, or the American bison, which trampled that country for centuries and centuries. Another good influence is the prairie dog. There are many grasslands that occur elsewhere in the world, making up the grassland biome type. And we have similar niches elsewhere in the world in grassland. Animals elsewhere in the world that occupy the same kind of niche are known as ecological equivalents. In the Great Plains region, we have the bison in grassland. In Africa, in grassland, we have the zebra and the hordes of grazing antelopes. And down in Australia, we have the kangaroo in grassland country. Interestingly enough, if a niche is vacant, you can bring a grassland animal from some other country and introduce it into the vacant niche. This was done in the case of Australia with the rabbits, and they successfully took over Australia. In addition to the North American animals that we've already talked about, characteristic of grassland, there, of course, are many more. Animals like the broad-winged hawks, the rodents, particularly the ground squirrels, meadowlarks, jackrabbits, a great variety of insects, particularly the grasshoppers. In grassland Kansas alone, there are more than 300 kinds of grasshoppers. And ants, especially ants like the harvester ants, whose conical hills are so typically a part of our western grassland country. But now let's leave the grassland and move into more arid country, into the desert regions of southwestern United States. With respect to the deserts of the world, we have interesting pictures in our mind of what they look like. We have visions of sand dunes, palm trees in oases, camels and Bedouins. And for the New World deserts, we think of cactus. In actuality, the deserts of the world are characterized more by brushland. This would be the common life form of vegetation. And in North America, we have two kinds of desert biomes characterized by brush. In the northern part of the Great Basin region, west of the Rockies and east of the Sierras, we have what is known as the cool desert shrub biome, characterized in the northern section by sagebrush growing rather close together on good soil, in the southern part by shad scale. Indeed, this particular biome is known as the shad scale kangaroo rat biome, after the two dominant kinds of plants and animals which occur in that particular region. As we move farther south, we get into the hot desert shrub biome. This country in southwestern United States and Mexico is characterized by extremely hot temperature and very little moisture. Indeed, in Baghdad, California, there is a record of only 4 inches of rainfall in a 5-year period, compared for the same period with 13 feet of rainfall in the Chicago area. There are 3 major deserts making up this particular biome, the hot desert shrub biome: the Mojave Desert in southeastern California, the Sonoran Desert in this region, and the Chihuahuan Desert in the eastern part of northern Mexico and Texas and New Mexico. This hot desert shrub biome country in general appears barren, desolate, characterized by plants widely spread from each other, and quite often in many regions lying below sea level. In hot, dry country of this particular type, we find many of the plants adapted to survive in drying conditions. Such plants are known as xerophytes, and the adaptations are quite varied. For example, leaves exhibit many specialized characteristics. leaves being the areas of plants where much moisture could be lost. We find some kinds of desert plant leaves covered with shiny material, thickened, waxy on the outside, leathery, perhaps thick and succulent. The general color of leaves on desert plants is about this color, a sage green, which apparently cuts down on the heat taken in by the plants. Sometimes desert plant leaves will be folded during the hotter, drier times of the day. Certain desert plants produce leaves which are extremely small. Other plants produce leaves which are on the trees and shrubs for just a short period of time, and they're dropped. And still other kinds of vegetation, particularly the cacti, produce no large leaves at all. And instead, the leaves' place are taken by spines. When we think about spines, we usually think of protection on the part of the cactus against animals in the environment. In actuality, the spines may be much more important in protecting the cactus against the environment, the heat and evaporation loss. One becomes particularly aware of this fact when noticing the amount of shadow which can be cast by the spines on a cactus, thus cutting down on the temperature of the cactus close to its surface. Because many of these desert plants are lacking in leaves, there must be some compensation in photosynthetic area, and so we find the trunks and the stems of many desert plants green and able to produce food, making up for the loss of food capacity in missing or small leaves. In addition, desert plants have specialized roots to take advantage of the available moisture. Deep tap roots that go down to permanent moisture sources, and shallow roots to pick up the transient rains that come down once in a while on the deserts. Plants also may be specialized for water storage, having succulent leaves, thickened stems, and great root reservoirs for water. For example, the giant saguaro cactus has a pleated stem, which is able to take up water and expand until finally the plant might be 90% moisture. Also, the barrel cactus, which we have represented here, can also take up moisture, and indeed has often been used as a source of moisture on the desert, although the quality of the moisture might be questionable. During the brief springtime, we find a tremendous abundance of annual plants, flowering plants, transient plants that come up, bloom, produce their seeds, and disappear. These then being adapted for life in a desert they could otherwise not exist in. The hot desert shrub biome is characterized by creosote bush, and indeed it's often called the creosote bush kit fox biome. However, there are many bizarre cacti and other xerophytes which are quite interesting in this particular region. Vegetation like the Joshua tree, like the organ pipe cactus, like the teddy bear cholla and the jumping cholla, the ocotillo, and the interesting bujum tree of Mexico. Although cacti are restricted to the New World, they have been planted throughout other parts of the world. And in Africa, there's a very interesting ecological equivalent of our New World cactus, members of the euphorbia group, which we see represented right here in comparison with the cactus of the New World. Very difficult to distinguish between the two types that have approximately the same kind of niche. Animals as well as plants are adapted for survival in rugged, arid conditions. We find many of the animals conserving water in, as a case in point, the hump of the camel, where water is stored in the tissue. We find animals producing dehydrated urine and dry feces. We find the animals getting the water out of the succulent vegetation, or in the case of the kangaroo rat, actually extracting water chemically from its food, the so-called water of metabolism. These desert animals seek refuge from the heat during the day by burrowing down into the ground, or climbing up into shrubbery, or standing in the shade of vegetation, or perhaps being active only at night or at twilight time. These animals have special adaptations for movement across desert conditions. They can travel across the sand on fringed feet, as is the case with some of the lizards. Another characteristic of our desert animals is their camouflage, like the grassland animals, in colors of gray and brown. In desert country, there are many interesting specialized niches in which animals live. For example, the night lizards living beneath the bark of the Joshua tree. The variety of birds like the elf owl and the Gila woodpecker, which nest in the trunks of the giant saguaro. The cactus wren building its nest in the tangled spiny protection of the cholla. There's a tremendous struggle for existence in the desert, and this is perhaps why so many of the plants have spines and thorns, and why so many of the animals happen to be poisonous. Although the desert, as its name suggests, might appear to be deserted, in actuality, there is an interesting array of animals occurring in the deserts. Most of them are secretive, not often seen, and yet they're well worth the seeing. Interesting animals like the ring-tailed cat or basilisk, the antelope jackrabbit with its extremely long ears, a variety of unusual desert birds like the roadrunner and the phainopepala, many interesting and bizarre insects, rodents like the antelope ground squirrel, and many reptiles, particularly lizards and snakes. The reptiles do well in desert country where the temperature warms up their body so that they can compete with mammals which have an internally maintained warm body temperature. In our southwestern desert biome, for years we had a vacant niche, a niche for a camel. During the 1850s, camels were introduced into that region and for many years swayed back and forth across the sand dunes, but finally became too much for the army which introduced them and now have disappeared. In 1820, Major Stephen Long, leader of a government expedition into the arid regions of the West, described that country, the so-called Great American Desert Country, for people of his time. In his words, in regard to this extensive section of country, I do not hesitate in giving the opinion that it is almost wholly unfit for cultivation, and of course uninhabitable by a people depending upon agriculture for their subsistence. Although tracts of fertile land considerably extensive are occasionally to be met with, yet the scarcity of wood and water, almost uniformly prevalent, will prove an insuperable obstacle in the way of settling the country. When we look at this country today, we find that Long was wrong. In the semi-arid grasslands have developed great ranching with cattle grazing, and more recently the development of grain crop agriculture and varied other kinds of agriculture. In the desert regions, with the advent of irrigation, we have seen develop agriculture, and more recently, great resort centers and havens for retirement. However, man should keep in mind with respect to these arid and semi-arid regions of the world that to date he's only been able to manipulate the environment on a local scale, only to make local oases in the deserts and in the grasslands. Meanwhile, as long as the characteristic climatic patterns continue in this semi-arid region of our world, there will always be the danger of a trend, a succession, back to the climatic climax, back to the perennial grasses, back to the brushland of the desert, or perhaps even worse, back to a disclimax, ruined countryside, ruined by man. And many a civilization and its ruins bear witness of these dynamic forces of nature at work in the world's deserts and grasslands.